All right, so when you graph log functions, we are going to use the change of base theorem to type them in. So when I have log base 4 of x, the first thing I need to realize is that's the same thing as log of x divided by log of 4, and that's how we're going to put this into the calculator. So we are going to use the y equals feature. If you have anything on your calculator, you want to make sure you're clearing that out. Make sure that none of your plots are selected because that could do bad things. So we're just going to do log of x. This is your x key right here. And make sure you close the parentheses on the x. Divide by log of 4.
I forgot where the x key
I know, that was
It's this one right here. Right here. It's the one that has x.
T theta n.
Right there. And this will be what it looks like when you type it in. And then if your window is already set up to a standard window, you could just push the graph key. And mine is, and so you can see it looks like this. If you are not on a standard window, you could use zoom number 6. That gives you a standard window. So it appears that this graph starts on the y-axis, but it doesn't really tell us what's happening on the y-axis. So using the table feature can be handy. So I'm going to do second and hit the graph key to get the table feature. And if we go back to 0, we see that it says error. So what that means is on the y-axis there is an asymptote. A do not cross line.
Do not pass go.
And that's because we cannot do a log of a negative number. And so we can get a few points off of here. So at 1, it's at 0. At 2, it's 0.5.
At 4, it's at 1.
At 4, it's at 1. You can just grab a few points. At 8, it's at 1.5. So it's not going to grow super fast. And then if we go back to the graph, we could also see how they're getting some of these points towards 0. So if you use the trace feature, you could actually put in, say, 0.5 and find out that it's at negative 0.5 down here. You could put in 0.25, see that that is actually negative 1. Just get a couple little points in there and just show that it goes this way. So it goes down, 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 almost vertical, but it will not cross this asymptote. So the other thing we need to talk about with this is domain and range. Domain and range of this function. So domain is the x's. So it only exists on the positive side. So for the domain, we would say that x is greater than 0. And the range for all of these is going to be all real numbers. And you can use the little double banded R for all real numbers because the y values will go down forever, up forever, even though they do slow down. So the range is going to be the same on all of these. It's the domain that's going to be changing. And that's because there are certain numbers that cannot be put into a log. You cannot take a log of a negative. Okay?
That's what she said.
All right, so number 2, actually, we will not have to use the change of base theorem because it is a standard log. So if we go into the y equals menu, we could just do log of x plus 3, just like this. So I did not have to use the change of base theorem on this one because it's base 10, and we have a button for that. So yay for us. If we graph this one, notice it's going over a little bit. The x plus 3 moved it left 3 units. So basically, if we just move that asymptote over here to negative 3, and we get some points from the table, we'll be in business. So I'm going to go into the table.
Error.
And I'll go towards, so negative 3 is where the asymptote is. Negative 2 is at 0. And then we'll just do like 7 is at 1. Maybe something in the middle. 2 is at like 0.7. So you don't really have to put a lot of points in here to see what the shape's going to be. And then it will just curl down. You could get some exact points, or we could just show that it goes down on this side. Keeps going over here. So what is the domain for this one?
Yes.
X is greater than -3.
X is greater than -3, and then the range is just going to be all real numbers. So we want to be able to graph it and come up with the domain and range. So what we're doing with the domain is this part can never be negative. Can't be negative. So that's why when I have the +3, -3 is where this is going to start. It also can't be 0.
What happens if you have an x equals log of y? Can you do that?
Then you'd have to switch domain and range, and it wouldn't be a function, so you wouldn't be able to graph it on here.
Okay.
So yes, sometimes they will switch the x and y around and do some things, but you would have to do one of these and then switch the x's and y's from your table to do it,
What a bum.
because this only graphs functions. Okay, so 2 more. Really quick, let's just get this done. Shh. So on this one, we're going to have to set up the change of base theorem because it's not base 10 and it's not a natural log. So we're going to have log of x plus 2 over log of 5. And then on the end, you're going to put -3. So this is what it'll look like when we type it into our y1 line. So we will have log x plus 2 divided by log of 5. And then we'll put a -3 on the end. So it'll look like this. Here's our fraction.
Wait, so you don't have to put parentheses around
You could put parentheses around the whole fraction, but it's going to assume, because this is not in parentheses, that it's separate.
Okay.
And then if we hit graph, it's starting over here at -2. It's also starting a little bit lower. So our asymptote will be at -2 over here. And then we can get some points. So go into the table. So -1 is at -3. And then the next easy one is 3, -2. And then you could do another one if you wanted to, or we could just kind of put the rest of it in like this. And so this part made it go left 2. This part made it go down 3. It has the same kind of patterns that we've had for other functions that we've studied. So that's why this one is a little bit lower. So what about domain? What would it be? Suddenly the room gets perfectly
Greater
silent.
than -2.
So x is greater than -2. And the range, all real numbers.
Not the same thing.
Pretty much the same.
Okay,
I'm
so,
supposed to draw it.
Infinity.
so I went into the table and got a couple of points.
I mean the range symbol.
Oh, so it's just a bar and a bar make the R.
Bar, make the R.
I didn't really mean to make that
I
right,
make
but
an R
it's just an
with
R
this
with an
bar.
extra bar.
But you're rap god, so
Okay, so we've got one more. So before we start, can you guys predict how this one's going to move?
Let's go.
Right 2, down 3.
Good. So this is going to be right 2, and that's going to be up 3. Good job. So that is correct. So when we set this one up on the calculator, we will have log of x minus 2 divided by log of 3, and then we'll put a +3 on the end. So we'll have log of x minus 2 over log of 3, and then +3 on the end. Okay, when we graph it, it looks like this. This one starts a little over to the right, so it did go right 2. So our asymptote is over here at +2. And we can get some points from the table. So we know that 3 is a point, 5, 4 is a point. Let's get one more. Okay, so 11 would be at 5. 8, 9, 10, 11 would be at 5. So I'm just getting a few more points in there. And it looks like this.
How many points do we need on the homework? Just three?
I would say 2 or 3, enough that you can kind of figure out where it's going to be.
Since we're minimal.
And then make sure that you're showing this is going down towards the downward part of the asymptote. This is going off forever this way. All right, so what's
Do we
the...
have to put range if it's always the same?
Yes. So it should be easy points. So the domain, what's the domain on this? An X
Greater than 2.
greater than 2. And then the range is
Bar,
all real
bar,
numbers.
Do
APR.
you like green eggs and ham?
Sam, I am.